Okay, so we are recording now. So first of all, welcome everybody to this demonstration on SRE course. If you could see in my slide, we are also mentioning cloud performance engineering in DevOps, right? So it's the combined course of both where we take care of cloud performance engineering. We'll go over it. What is this cloud performance engineering? You might have heard of Java performance engineering, right? Mostly, when we talk about performance engineering, we talked about the application performance monitoring, tuning of the code, right? Optimization queries and those things, uh, taking heap dump, thread dump. But this particular course talks about the cloud, the infrastructure, from the infrastructure perspective, right? That's why this name cloud. And we also have something for the Java performance engineering. I will share that in a bit. And it's SRE course, full-fledged SRE course for anybody who is looking forward to transition the career to SRE. This course is going to immensely help you. Okay, so before we get started, let me introduce myself. My name is Roshan. I'm with Isha from last 4 years. Uh, I have overall 16 plus years of IT experience. I started my career as a Java developer, and then I moved to performance engineering, Java performance engineering. I was involved into performance testing. I was involved into DevOps, automations. Currently, I'm working as a principal SRE with one of the reputed giants of the world, uh, retail giants of the world. Right. So that's a brief about me. From last 8 years, I have been into SRE, complete SRE domain, where I take care of reliability, performance security, cost optimization of the product, right? And teaching is my hobby. That's why I love to share my knowledge whenever possible. So I do take care of sessions in multiple other platforms with IntelliPath, Edureka, Simplilearn. I am also associated with them. Okay, so this is going to be the agenda of this session. We will start with a question, and I would like this particular demo session to be interactive. You can ask whatever confusion you have, doubts you have. You can feel free to stop me at any time, right? And I can assure you that there will be takeaways, there will be learnings for you in this session itself, 1 hour of the session itself. That I can promise you. We'll start with a question. We will understand about something software development and deployment evolution, how software has been evolved over the years, develop from development perspective as well as from the deployment perspective. We'll understand that the journey of any software development. And then we'll talk about the course, what value it adds to your resume, to your knowledge, and what you can do with that, right? And then Q&A. That's what we're going to talk about. Okay, so I'm going to start this session. Before I start, right, I would like to know something about you. Uh, those who have joined, just quickly, guys, are we all performance testers, engineers here? Type yes, PE, PT, PE, or years of experience. Performance testing, PT, you can use. Performance engineering, PE, you can use. And how many years of IT experience you have? Or if you are into functional testing, DevOps, operations, right, support, feel free to mention that quickly, just in few couple of words. If you could just put your experience, I would understand about my audience better. Okay, I see platform engineer with 8+ years of experience. Okay, performance testing with 1+ year experience. Okay, performance testing with 14 years. Okay, performance testing with 5 years, 10 years, engineering. Okay, performance testing with 7 years, functional tester with 2+ years. Okay, 2 years, good. So most of the folks are from the performance testing. So I will talk in that context. I request everybody to be on mute. You can feel free to unmute yourself and ask questions, but if you're not asking any questions, I highly request you to be on mute. Feel free to unmute yourself and ask questions, okay? Good. Production support from 14+, Vivek. Okay, Vivek. Good. Performance testing, good. I got to know about my audience. Thank you. Nice. Okay, so we will directly go with the questions without further ado. Okay, so this is the question. Very simple question with simple four images. Are performance engineers, or I would say IT engineers, okay? I'll just use this word IT engineers because most of the people join in this group of performance engineers. So I have explicitly mentioned that, but let's talk about from IT perspective, software perspective, software engineers. Expected to know this. What do you think from your experience? I see people with multiple, various years experience, 1 + 2 = 14 years I see in this group. What do you think, guys, from your recent experience of the market, of the industry that we have as of now? What do you think? Do we need to know this? DevOps, microservices, containers, Kubernetes, Docker, cloud, cloud knowledge. Do we have this? Do we need to know this?
Yes.
Right?
Yes, yes.
I do see people are saying Sada, Bhavya, Sudhakar. Few people also mentioned in the call. Yes, right? Absolutely. But if you rewind your career, let's say 5 years back, maybe this question would not be relevant that much because these things were picking up. And I was there in this transition journey. Um, so I understand the bridge, right? We need to know this, and you'd be in going through interviews, and people would be asking, what is containers? Do you know Docker, containerized applications, Kubernetes, right? People from performance engineers, they would be asking DevOps, Jenkins pipeline, have we created these kind of things? Do we know cloud, AWS? What are the services used for, right? Microservices, how microservice different from monolithic? So these are the very typical interview questions you must be having, apart from the general performance testing and engineering questions, right? I'm not talking about the Jmeter tool or your thread dump, heap dump, those kind of engineering questions. I'm not talking about that, or response time, throughput. In general, about the technology. This is applicable to anybody in the IT, okay? Not just performance engineers, but anybody. And we will take this course from performance engineering point of view and from the SRE mindset, right? This is what. So we all have agreed here. It is very essential. Kamakshi is mentioning it is very essential, right? Now the question is, where do we learn this from, right? Do we have any place where everything is consolidated, right? That's the major thing because there are a lot of content in the web, right? We are in the information technology, right? Revolution, I would say. A lot of information, but what is important for you, performance engineers, SRE engineers? How much is important, right? This is what we need to know, understand, right? So that we can tackle the interview better, we can have a better preparation. So we'll understand that. Okay, got it. So let's understand this in a better perspective. Why these four things are coming up now? DevOps, microservices, containers, and cloud. Why these things are coming as of now? See, it has not come just like that. To understand, we need to understand how the software has been developed, the how evolved, how the software industry has evolved over the years from a development perspective and from the deployment perspective. Then we will get the answer why these four things are important. Okay, I'm going to move to the next slide and you will get the answer. Okay, now I talked about four things: DevOps, which is here, right? DevOps, which is here, microservices, containers, and cloud. These things are not random. We need to understand how software has been evolved or evolving over the years. And that's where it is the need. It has been the need for many years, 6 to 7 years, I would say, where I have been seeing this transition and people are still picking up because when I ask questions in the interview, these things are important. Anyway, even if you go to attend any interview, these things will be the topic because every company is started to adopt these things. Every company is adopting DevOps. Every company is developing microservices-based architecture, not monolithic. Very few companies are deploying software directly on the VMs. We are deploying as a containerized applications, and we are using cloud. We are not using on-prem, right? So this is the setup in 70 to 80% of the company, and other companies, other percentage, 20 to 30% are moving in this particular. But if a company is started over, let's say, last 7 to 8 years, you're gonna find these things. So this is the region. This evolution, if you understand, this is the region why these things are important and relevant to the current market. There may be other technology which may come later, right? Obviously, that has been the trend of IT, but this is the situation right now from 2010 onwards. And companies are adopting DevOps. Why? To speed up the deployment, right? So we need to understand what is DevOps. To understand DevOps, we need to understand what is waterfall. What were the drawbacks of waterfall? How Agile improved the waterfall process, and then how DevOps made improvement in the Agile approach, right? We need to understand the transition. Same thing for monolithic to microservices. What is the difference? Why people are talking about microservices nowadays? Everything is API based. Everything is microservices based. Why? Why? What is the reason? Why we are not deploying directly on the VMs now, applications? Why we are talking about containerization? You need to understand the major, why the region, the cost, right? Right? And what are the market trends people are talking about here in the containers? You will hear the word like Docker and Kubernetes. Why people are talking about those things? And obviously in the cloud, earlier data center and now cloud. Wherever you go, people will ask you, do we have cloud experience? Do we have certifications, right? This is why. Okay, so let's understand each of this briefly, okay? And then we'll talk about the course, how we have taken care of these four aspects, okay, in the course. Let's talk about DevOps. So to understand DevOps, we need to know the flow, waterfall. In waterfall, what did we do? We developed the entire software at once. We ignored, during the development process, we ignored the testing and all. Quality validations, we did not do that. We developed the complete software. Complete software. It took 2 years to just develop, focused on development. We did not do any testing. And when we started to test after completing the software, we found there was some architectural flaw. The application is not able to scale up. Some fundamental architectural flaw. Now, it was very difficult to go back and make those changes. You have spent 2 years in developing the software, and now I'm talking about the application cannot scale more than 5 users or 10 users. Or there is some architectural fundamental flaw. If you go and correct it, again, it's a very costly affair. So no point, right? So that was the approach, waterfall. Okay. So it's not like we should always talk bad about that. It was the first thing people tried in 1980s when the software development started. Then we learned from our mistakes, shortcomings, and then we improved. How did we improve? Through Agile. What did we do? For the same software, we split that. We did not develop all at once. We split the development into multiple phases. We call them as sprints. One part, second part. We went in a very linear fashion. We developed something, we tested it, completely tested it thoroughly. We went to the customer, took their feedback. Okay, are we good? Are we going good? We tested functional testing, performance testing, security testing, UAT testing. We did all sorts of testing, penetration testing for the one phase. Then we moved ahead. We took the customer feedback and we moved ahead with the next phase, right? Again, we developed something. Again, the same process goes on. It was a much better approach, right, than waterfall. Less likely to see any surprises at the end when the software is completed, application is completed. Very less likely we'll get any surprise at the end, right? Because of the approach we have taken. Much better approach. Still, we are a lot of companies I would say 60% of the companies still are agile, or I would say not 60%, let's say put 80 to 90% are still agile, not completely into DevOps. So I'll talk about DevOps. So what was the problem with agile? Okay, I do see people are uh, typing something here. Okay. No, the problem with agile, what was that? See, the development people and operations people, when I say operations, I'm talking about the testers. It took a lot of time. Okay, I'm going to ask you a question to make you understand DevOps in a very simple manner. When the code is ready, okay, let's say when the code is ready, developer is done with the coding. What do we want to do with that code? Tell me. Think logically. There is no, I'm not expecting a lot of technical knowledge here. When the code is ready, eventual, what do you want? Eventual. Let's not talk about all the phases. Eventual, what do I do? What do I want to do with that particular code?
Deploy.
Deploy. Absolutely. Where? Deploy to production. This is what
And
I want. This is what I want, right? I want to deploy that code to production. Absolutely bang on, right? Absolutely correct. But I cannot take that risk, right? I don't want to get surprises in production. I don't want user to get any surprises from the functional point of view, from the performance point of view. We don't want to get any surprises. So what do? We test. Developers do the unit testing. Functional testers does the functional testing. Performance engineer does the performance testing. Security engineer does the security testing, right? UAT engineer do the UAT testing, system integration testing, and all those. Because we don't want to get surprises in the production. These activities take a lot of time, Functional testing, again, if it is done manually, think about time, right? If it is done automated, it's good. But if it's done manually, it will take some time. Testers will raise some defects. It will get fixed by the developers. Developer will say it's not a valid bug. Some environment is like back and forth communications keeps going. And what happens at the end? Same again, performance testing will start. It will take some time. Security testing. What happens at the end? Delayed. The software deployments gets delayed. The code was ready 2 months back. But because of the other testing, it delayed the process. Any company, think about, if you own a company, would you like to fix this problem? Think, honest. Code is ready. Developer is like, we are done with the code. Would you like to fix this process? The time it takes from the code is ready to get to till the time it gets deployed to production. Do you want to reduce that time? Yes or no? Every company, everybody will say yes. No doubt about it. Yeah, if you don't want to work, you can say no, but everybody would like to deploy, right? So what is the process? Automation, right? Automation, removing the silos between the development team and operations team. When I say operations, all the testers, deployment engineers, all those comes under operations team. I want to remove the silos, right? I don't want to have any environment issues. And I want all the test cases to be automated. Functional testing to be automated using Selenium. Performance testing should be automated using Jmeter. Some automatic triggering of the code, right? I want when a code is deployed, when a code is ready, when the developer has uploaded the code to, let's say, GitHub, I want a series of jobs, series of executions, unit testing done automatically, functional testing done automatically, performance testing, and now eventually when everything is passed, all the quality validation has passed automatically, the code I want to get deployed in the production. This is what DevOps solves. So DevOps is nothing new. DevOps is agile plus automation. This is what DevOps. DevOps talks about better collaboration between the development team and operations team through automation. I want to reduce that time. DevOps focuses on reducing that time. When the code is ready, and before it gets till the time it gets deployed, that time it takes, right? If it's a manual process, it takes a lot of time. So DevOps focuses on that. Every company, if you work already, you know, but every company is focusing on that. That's why we have automation engineers, we have performance engineers. You guys must be working with Jenkins, creating pipeline, being part of pipeline, right? So that's what DevOps does. Are we clear on this first page? DevOps, waterfall agile DevOps. Please give me a thumbs up. Yes, in the chat. If you have any question, feel free to ask. Any question? Guys, yes or thumbs up would help here. Okay. Now, moving on. Monolithic. What is microservices? See, earlier, the the code, right? The business logic. I want you to focus on the business logic. We have web server, we have application server, we have a database server, 3-tier application mostly, right? 3-tier application. Web server, application server, and database server. Let's focus on the application server, the middle part, where all the code resides. When you have all the code with huge dependency, right? What I'm talking about, let me show you something. Give me a minute. Okay, I will just bring out a diagram quickly. I already have a diagram. I just want to use that diagram. If I draw, it will take us some time, but I can use that diagram. Okay, just give me 30 seconds. I want everybody to focus on this diagram. This is a 3-tier application. Web server, application server, and database server. Focus on the application server. Application server mostly has the modules, right? Module 1, module 2, module 3 means some functionality, right? Some code, business logic, payments module. Right? Let's say consider Flipkart application. You have different sections for electronics item, for clothing store, flight bookings. You have different sections, right? Consider those as the modules. Payments module, right? You have different sections. Consider those as the modules. And what modules have functions? We write functions, right? Code. I'm calling it, let's say, this module M1 has M1 F1 to F20 code. M2 has F21 to F50 code. M3 has some code. M4 has some code. When there is a huge dependency, when I'm writing F1, I'm calling other functions also. Other modules, functions from other modules also. When I'm writing F51, I'm calling M1, M2, M4 functions also. Huge dependency. The functions are being called everywhere and anywhere and everywhere. This, and when we deploy as a tightly coupled unit. You get like one jar file. You get one jar file for all the functions. In one jar file itself, let's say I'm talking about Java application. In one jar, when you package it, you get one jar file where all the functions will be there. What is the problem? Huge dependency. With huge dependency, that we call that monolithic. What is the problem with this kind of architecture? Let's say if one function fails, for some reason, F1, F2, any function fails, it will impact the complete build. First of all, even for the smallest change in any function, let's say a developer fixes some code. Let's say developer has fixed F22 code. There was a bug, F22 code developer has fixed. It has to build the entire code base again to generate a new jar file so that it can be deployed to the servers, production server or QA environment, performance environment, right? Entire code base he has to run. And the issue with one function can bring the entire application down. Yes or no? Because of huge dependency. The code base, the functions are being called everywhere and anywhere and everywhere. There is a huge dependency across all the modules. So the issue with one of the functions can bring the entire application down. We want to solve this problem. How can we solve the problem? By reducing the dependency, simple. Don't call the functions, reduce the dependency. So we split that. This is what we call it microservices. We split M1, M2, M3, M4. We kept it separate. I'm not calling the functions directly now. Each module is an independent unit. Each module is an independent unit. M1, M2, M3, M4. And let's say if M1 this module needs some information from M4, how it will get it done? Through API calls. I'll give you a better example to make you understand. Everybody uses Make My Trip application? Yes? When we go to Make My Trip application, we book tickets, right? When we give source, destination, date, we can see information from all the flight carriers. Indigo, Air India, Air Asia, whatever. 10, 20 flight carriers. How come Make My Trip has all the details? Do you think Make My Trip owns all these airlines? Does Make My Trip have the database access of all these airlines? It is done through API call, right? GET call. API calls. So Make My Trip, when you click on the search button, internally what happens, Make My Trip calls GET calls to all the airlines, and information gets populated in your screen, availability on a particular day, time, right? This is what I'm talking about. If M1 needs some information, it can call M4 through API call, right? That's it. So this dependency could be reduced. So what will happen if let's say if F1 has issue, will it impact F71 or M4 in microservices world? If Indigo is not working, will it impact Make My Trip?
No.
That's what we call it microservices based architecture. One functionality of one module is not going to impact the functionality of the other modules. Every development is happening towards microservices world now. Earlier, it was monolithic. We were getting one jar file, let's say considering the code was getting developed into Java. We were getting one jar file for all the modules. Now I will get different jar files. Module 1 jar file, module 2 jar file, module 3 jar file, module 4 jar files. Separate jar files. It's good for the application availability. Even for the reliability perspective, it's always preferred to use microservices-based architecture, so that if the issue is with one function, it doesn't impact other modules. And it will also write, let's say if developer has fixed something in M1, developer need not worry about M2, M3, M4. He can directly deploy this code, small code, right? Easy to deploy. I can have a better DevOps pipeline because I don't have to redeploy every other code. I have to only focus on M1. So easy from a development perspective, easy from the. I request everybody to be on mute. Everybody, please go on mute when you speak something. I think it's a fair ask, right? When you're speaking, you can unmute. Absolutely, you feel free. Okay, so that's how it is done. M1, M2, M3, M4. Right. So this is about the second part. Okay, are we good with this approach? Why microservices is important now? And monolithic, how different it is from microservices? Microservices, that is called microservice. When you split your monolithic applications RAM, each sub application. Let's say you have a bigger application and you split that into 4 sub application. So each sub application is called microservices. You can call it application also. It's all about arranging the code base. Okay, Ram. It's all about arranging the code base. You can call that small application as application also, application 1. So application 2, application 3, application 4. Or you can call it microservices. I'm giving a term here. Microservices, small independent application is called microservices. Not obvious, not always Sada, right? Because of Microsoft, no, it's not like the complexity increases. It simplifies the complexity. I just explained you how. I just explained how it simplifies the complexity. Microservices. If you have a bigger application, when you have a smaller application, you did not worry. You can deploy one jar file. But when a code base is used, you have a different functionalities. Let's say Flipkart.com. Let's say, for example, earlier they did not have this flight booking options, right? Or they started with book selling options. They are integrating different things, flight, other bookings. Why do they want to have all the code base in one jar file? Does it make sense for them to have every code base in one jar file? Think about it.
So what if the API calls are dependent?
Now then dependent, when I say, make it as part of the same microservice. The entire purpose of microservice is make it independent.
No, for example, like in Make My Trip, when we go for like payments and all, we call like third party APIs, right?
Yeah,
And
third party API.
in the same way, we want to like like sometimes we want to send like for kind of like a confirmation email to the user, and that is like we can say like that is another microservice. So so like how they call like
See, Pankaj, the entire purpose is not to call the function, right? So that the code base can be managed independently. I'm not telling M1 would not require M2. Or if M2 is down, let's say if M1 needs some information from M2 and M2 is down, M1 would be still fine. No, it will not be fine. The entire idea is to manage your code base. All I want, that one small application failure, I don't want a downtime because of that. Complete shutdown of my application, which was happened in the monolithic case, because there was a huge dependency. If M1 needs some information from M2, I will call the API, get call, post call, right? I will, if I need to update something, or if I need to get some information, I will do a get call. M1 will do a get call to M2 get the information. It's not like I'm not depending on M2. I need to do a get call, I will do that, but I'm not calling the functions. If I have to deploy something in M2, I will not redeploy M1 also at the same time. The purpose of microservices is this.
Okay. So rather than calling the function, I'm just calling the APIs.
Right. Okay. Same thing, right? So
Yeah.
you got it, or we still have some question?
No, understood. Yeah.
Got it, right? Yeah.
Yeah.
So the main purpose is to not to remove the
Okay.
dependency from the code perspective. I don't want the
So
code to call. Yeah, go ahead.
okay. So I can say like if let's say I have 4 modules, and those 4 modules can be deployed on 4 different servers.
Exactly. Yes. Different jar files. They can be separate
Yeah.
servers. They can be deployed independently. I don't want to deploy M1 first, then M2, M3, M4.
Yeah.
They can be deployed independently.
Okay. Understood. Thank you.
Yeah. I'm showing you 4 jar files, separate jar files. They can be deployed on different servers independently. Independent. The entire idea of microservices is to make it independent.
Okay, so interaction between these two module always will by API calls or any other method also is there.
No, mostly API call we do. Mostly
Okay.
API call. Get call, post call, right? Those are
Mm-hmm.
put call, delete
Okay.
call. Those API calls are the mostly popular ones that we
Popular
always
one.
do. Yeah.
Okay.
That API calls are through HTTP protocol only.
Okay.
So, HTTP or HTTPS? It
The
depends.
both are
Yeah.
same. Yeah, the more
Okay. Yeah.
secure. Yeah. So
Okay. Yeah.
okay. Now coming to the third part, containers. The question is, now we have split the application. We made small applications. Now the question is, can we still deploy them on the VMs that we were always doing? VMs, virtual machines. Earlier it was physical server, right? People were directly deploying on the physical server. A lot of wastage were happening. So around early 2000, we had this revolution called virtualization. We did the virtualization and we revolutionized the way we deploy the software, and we started deploying on the VMs, right? VMs, virtual machines, right? Everybody understands virtual machines, right? Servers. Now we split the applications, we made it microservices, and there was another technology came 2015, just 7 to 8 years back, which revolutionized again, like the way virtualization revolutionized. There is another technology called containerization. We need container engine to install on the VMs, and we can create containers and we can deploy microservices on the containers. It was all done to for the cost optimization. So just to make you brief, I could cover so much. We need a longer duration discussion, 1 hour, 2 hours, to understand how do we create containers. We use Docker container engine like Docker to create containers. On the VMs, we deploy Docker and we create containers, and then we deploy the microservices there. And it takes very fractions of compute and RAM from the VM, right? So these two are deadly combination. Every company is doing it. Microservices plus containers. That's why you would hear the word Docker, Kubernetes, right? Whenever you use the word Docker and Kubernetes, they are deploying microservices on the containers, right? So this is about the containers. Now again, cloud, right? Again, earlier people were using on-prem. Not everybody can afford on-prem. So we have the cloud. Cloud has evolved immensely over the years now. We have AWS, Azure, GCP, so many cloud providers. So we all need to know cloud because this is where the applications are deployed. We need to learn cloud, right? So that's why these four things is the thing which is going on in the IT, and everybody, performance engineers, software engineers, functional engineers, software, anybody in the IT, everybody has to know this, right? That is where these things are placed, right? So now we will go over this course, what this course brings to the table. In this course, we cover these four aspects. We talk from the cloud perspective. We talk about AWS. And this course takes everything from scratch because I know people are looking for a transition. Most of the people have never worked on cloud. They've never worked on containers. They don't understand containers. They understand VMs, right? How do we create containers? In the cloud, how do we create VMs? Like those things. So this course, the main USP of this course is that we take it from scratch. Anybody can take it up, right? Freshers with years of experience. Because let's say if you are a performance tester, so you're just working on one tool, let's say Jmeter, but you need to deal with all these things. You need to deploy application. You are working on the cloud. You're working on containerized applications. You're working on microservices. You must be doing API testing, right? So API testing could be done on monolithic application as well as on the microservices. It could be anywhere. right? So we need to know all these things, right? And that's this particular course talks about that. So what I'm going to directly delve into the course, and then you'll understand better. So from the cloud perspective, we talk about AWS. From a containers perspective, we talk about Docker and Kubernetes. How do we create containers? How do we deploy microservices? That's not enough, right? In production, we need auto scaling of containers, auto load balancing of containers, auto healing of containers. That is done by Kubernetes. So in this course, we talk about that. And in DevOps, we'll talk about Jenkins, right? So let me go over the course, right? So this is the link, guys, everybody. This is the link of the course. And let me explain you what this course, how we take up. So there are, I'm going to share this link. You can go over a few demo sessions are there. We are taking one of the demo session as of now as we speak. And there will be other demos also. We will take 1 or 2 demos. So let me talk about the course. So we talk about first thing I told you, the cloud. We take up AWS. It's not like if you take AWS, why not Azure, why not GCP? We have to start from one. We need to know one cloud. Once we know any one cloud, you can learn any other cloud providers. That's how I learned. I have been working in 4 cloud providers as of now: AWS, Azure, GCP, and Oracle. I have certified in all these 4, architect associate certified in 2, and in 2 I'm professional certified, right? So I've been working on multiple cloud service provider, but the way I have started my journey is through learning one. So you can also start with learning one cloud, and then you'll understand, because the use case would remain the same. Why we use cloud? Because I want to get the server, because I want to deploy my application. I need to get the storage. Netflix needs so much of storage. They have so much of content. They get it from AWS. They deploy things in AWS. Hotstar, they deploy AWS using IPL. They do auto scaling. The servers, because their users increases in some peak time, right? So they auto scaling. So we'll talk about all these things in the cloud. We'll talk about load balancing. We'll talk about auto scaling. And we use different services. So I'm not going to go over this because it will be very new for you. But if you are looking for details, these are the topics we're going to cover. We'll talk about EC2, we'll talk about IAM, we'll talk about storage services, we'll talk about database services, we'll talk about networking, we'll talk about load balancing, auto scaling group, how it happens. Because auto scaling group is one of the very important topic from a performance side. Because in production, think about, right? Let's say you are working in an application like Netflix or Hotstar. In the cloud, important thing is cost optimization. In on-prem, you have purchased the servers. Forget about it, optimization. You have already purchased the servers. How would you do auto scale? But in the cloud, you have not purchased the software. You have not purchased the servers like on-prem. So auto scaling becomes very important. Throughout the day, most of the people, let's say one match is going on, let's say IPL match is going on. IPL match goes for 3 to 4 hours. In 3 to 4 hours, do you think you need servers all the time? The number of users watching at the television or mobile set are the same or across on this during these 4 hours? No. There will be half an hour or 1 hour where the users would be more. So you need more servers there. So how do you auto scale? Right? So we'll talk about that from a cloud perspective. Everybody would get to, everything is hands-on. Everything is hands-on. So everybody would have this cloud. I would guide everybody on the cloud account. How do we get access to the cloud account? And you guys can practice this without spending any amount. Because every cloud offers free tier. So I'll make sure that you don't spend any cost there if you follow my advice. So we will learn about a lot of services here. EC2, where we get the server, S3, where we get the storage. SQS, where the developers use for the queuing mechanism. VPC is for the networking. IAM is for the users, access and groups. EKS for Kubernetes. So we'll talk about a lot more services. We have database services. We have Lambda. We have Beanstalk. We'll talk about a lot of services in the cloud. Okay. So that's the first thing. We'll talk about Linux. What I have realized that people are comfortable with Windows. If I ask you right now as well, I'm not going to ask any question right now, but you can ask yourself. If I ask you in Windows, can you open a file? Everybody knows how to open a file in Windows. I'll ask you, can you search for a text in a file and replace that with another text? Mostly 95% of the people can do that. Right? But if I ask you to do the same thing in Linux, I've seen people struggling, like not because mostly exposure, right? It is the same thing. It's just an operating system. It's all about the same thing I'm asking. Can you do this in the Linux? Just replace a word. There's a text file, search for a text and replace from using another word. In Windows, it's possible. Everything is UI. Is it possible in Linux? Yes, it's possible in Linux. But a lot of people will struggle. You can ask yourself, right? How to install something. Because fact is, the enterprise applications are deployed on Linux. The enterprise applications are not deployed on the Windows operating system for various reasons, licensing, security, right? Cost. All the enterprise applications that you work is deployed on Linux. So we need to be good at Linux. That the point is this. We need to be very good at Linux. How about Linux performance? In Windows, if I ask you Windows performance, you can do that. You can go to Task Manager and you can just go to Task Manager and you can understand which all processes are running. These many processes are running and these many CPUs are taking, right? If I ask you more questions, you can definitely do that in Windows, right? We have this tool, Task Manager. But if I ask you to do the same thing, go over all the processes, tell me which process is taking what CPU, what memory, what is the load average, right? How many cores you have, you will struggle. Most of the people would struggle. I'm not saying all. You can ask. We need to know the host performance. Let's say you have deployed one application in Linux and you are troubleshooting some performance. You can look at the process level, but if the host is not good, where you have deployed the application, your application performance will also struggle. So we need to know those things. What is load average? How to check these things? How to get comfortable with Linux, right? The simple, get as comfortable with Linux as you are with Windows. This is my tagline. And we talk about these many things. Then moving on, I'll come to these things. So software architectures, monolithic microservices, I'll talk about that. When I talk about microservices, where do we deploy microservices? We deploy on the containers. So we'll talk about Docker. Everything is hands-on. I'm going to show you everything. Commands, installations, everything is hands-on with commands, not just theoretical knowledge. No. I'm going to get the server. I'm going to log into the server, SSH. Okay, let me ask you a simple question. From this, I can understand. If I have a Linux server, like Linux server, we do SSH, right? And for Windows, we do RDP. Do we know which port we do SSH and which port we do RDP? I want everybody to type it. SSH, which port we do, RDP, which port we do. This is which one? Which one is what? Yeah, I want everybody to type it. One, two, three, four, five. 6, right? I'm getting responses 7 to 8, like 50%, 60% can answer, but not everybody can answer, right? So I'm going to create the VM, SSH to the Linux instance. I'm going to issue commands. I'm going to install things and show you how it is getting done. I'm going to show you how do we create containers, how do we deploy microservices. I'll talk about all the commands. Okay, everything is hands-on, is what I'm trying to tell you, right? Yes, I got answers, guys. 7 people have answered. Pankaj, Sagar, Chaitanya, Jaula, right? Vivek, 5 people. 5 people have answered. Right? Then we'll talk about Kubernetes. This course takes around 2.5 months. Okay. This course is a very elaborate course, and we take up sessions only in the weekends, evening, 2 hours, 7:30 to 9:30 p.m. So 4 hours a week. And we goes about 30 to 35 hours. 30 to 35 hours of live sessions. So you can consider like 4 hours a week. So in month, 16 hours. In 2 months, 32 hours, right? So if you need some more sessions, so 2 months for sure, and 2.5 months it can also go if we miss a couple of sessions here and there. So 35 hours is going to be the live sessions, and we also share some recorded sessions. The EG ones, EG topic. This is a very elaborate course, very complete course. You'll understand in some time. So we'll talk about Docker. We'll talk about Kubernetes here. Again, I don't want to go in detail right now in Kubernetes, but no, it's very important. Those who do not know. We'll talk about DevOps. How do we create CI/CD pipeline using Jenkins? How automated jobs gets triggered? How do we create performance job as part of CI/CD pipeline? We'll talk about that here. Apart from this, we'll talk about observability. From a SRE perspective, I'll talk about this. From a SRE perspective, we'll talk about what is SRE, what is fault tolerance, what is high availability, what is DR. We need to know these things. We need to know these things. What is incident management? Change management, the roles and responsibilities. We talk about observability, monitoring, Linux monitoring. What all to monitor Linux? Linux performance monitoring, debugging, CloudWatch, of Prometheus and Grafana and ELK. How do we monitor? How do we install? How do we monitor, create graphs, those things, dashboards? Along with that, we share recorded sessions. So whatever the recorded sessions, right, I have mentioned in this. So 8 hours of Java performance engineering course. It's going to be recorded sessions. So I'm going to share you the recorded sessions, right? You can find the recorded, the self-paced recorded sessions are here. I have mentioned it. It's going to be my recording only, shell scripting, Linux, because Linux is the very fundamental, right? If I take everything, it's going to take 65 hours, 60 to 65 hours. Earlier, I used to do that. It used to take 4 months. So that's why I have split this, and I have made 30% as the recorded session and remaining 70% as live sessions. Yes, it's going to be practical course. So that's why we have split this. Jaula, that's why we have split this. We have totally, we are covering 60 to 70 hours. Okay, totally. This course has 60 to 70 hours, but live sessions are going to be 35 hours. So you can calculate like this: 8 hours of performance engineering, this particular recorded sessions. Okay, this is going to be my recorded sessions. I'm going to share that with you. Earlier, I used to take this live sessions, but it used to take, as I told, 4 to 5 months. So I have split few things. You can ask me any questions at any time. This particular link has everything about JVM architecture, your how Java manages memory, GC algorithm, heap dump, thread dump, GC log, everything you have it here. Whatever you require for the Java performance engineering, you have it here in this link. 8 to 9 hours of recorded sessions are here. More than 10 hours, I think, okay? 10 hours. Here, you have it here in this link. This is going to be self-paced, right? Similarly, you'll have a self-paced for the Linux. So Linux, we have like 3.5 hours, right? I'll come to the questions. Just give me some time, okay? Let me complete whatever we have in the course. So Linux is going to be self-paced, right? And then we have for Python also, we're going to share. This is Python is not mine. It is from somebody else at Isha. So Python as well as Java. Java, Python coding and Java coding. You have it. Some recorded sessions here. Okay. And this is going to be the live sessions. What you see here is the live sessions that I take up. As you can see here, all the days wise, everything you're going to be given like this, a playlist. And as you can see here, we take up approximately 35 hours of live sessions here, right? About this course. So it shell scripting, eliminating toil. We talk about automation here. We talk about CI/CD pipeline using Jenkins. We talk about Terraform. We talk about Ansible here in this course, in this particular module. Then as I told you, we have Java, core Java, recorded sessions, Python recorded sessions, right? So we have split this 70 hours into live sessions as well as in the recorded sessions. Okay, this is about the course, how we take it up. So usually we start with cloud. This is how we start cloud. First fundamental thing is we start with cloud, and everything is hands-on, easy to understand. Is what we do from scratch. Then when I start this, usually we give Linux sessions, 3.5 hours. So you can do this along with live sessions, right? So we share one by one things. Then we talk about architecture, microservices, Docker, Kubernetes. Those are live sessions. Then we will share recorded sessions on Java performance engineering. You can go over that. Right? Then we talk about Jenkins, DevOps. Then we share recorded sessions on the Java coding and Python coding. Right? And that's how we complete things. Okay. Guys, are we clear on how we take up these topics? Now, I'm going to come up with the questions. See, Jayullah, I have seen Udemy courses, okay? It's not like only you have the access. I have seen Udemy courses. I have been struggling to get such a course, okay? You can explore, okay? We can explore Udemy. You can explore not just Udemy, other online platform as well, okay? You will not get what we have here, okay? Because I have been learning from those things as well, right? Over the years, I have learned use those things. But as a one place where we get things, right, in a very simplified manner, easy to understand manner, I have not found it, right? I'll not be even hesitant to say this is one of the best course. I have not put that in Udemy, and I don't want to put it in Udemy. right? This is one of the best course. If I would have got this course 6 years back, I would have paid any amount for this course when I was learning. Okay, so I can say like this to you. I can answer you like that, right? Because I know what they offer and what this course offers. You get what you need. You don't get unnecessary things. Everything is hands-on. You get slides for that. I'm gonna share uh, slides. So with every topic, right? Um, let's say I completed one of the batch. So I share a lot of slides, which is gonna be easy to refer slides. So I'm just completing with one of the batches, December batches. I started in the last week of December, and okay, this is not the one. One second. Let me show you. Yeah, here it is. So along with all the recorded session, you get these many notes, PPTs, my notes, all the commands that I use, all the YAMLs that I use, right? Everything you get here in this course. We're starting. We have started already about this course. So today was the demo. You can see the plan here. So if you go to this link, you can see this. Okay, we have already started. Today is 10th March, right? We are doing a demo, and we're gonna day one will be 17th March. Day two is gonna be 20, and we're gonna continue. Right? We'll continue.
Yeah. Roshan, so once we complete the course, where we will be in the how much weightage it will add to the resume, our career perspective, how
See,
much
if
opportunities.
you already know, let's say Jmeter, if you already know performance engineering, right? Let's say that, and if you attend this course,
Hmm.
you can crack. See, let me put this simple. You can earn any amount till 40 lakhs.
Okay. Hmm.
To be simple, or to give you a blunt answer, you can earn 40 to 45 lakhs per annum with this course if you have a right other knowledge. See, I'm not taking up JMeter here. I'm not looking into your other Java database performance knowledge also. So you need to take care of those things, right? This particular course talks about something specific from a cloud perspective, from Docker, Kubernetes perspective, from Jenkins perspective. If you have this, right, whatever we are offering here, and along with your performance testing skills, you can
Yeah.
earn up to so much.
Okay.
People have been earning.
Same. Yeah. Yes. Yes. So same like AWS. So can we use IBM Cloud? Is that IBM Cloud is also
Any cloud, as I told you, right? You can use any cloud. I am going to show you the demo in AWS
okay.
because this is how I'm going to take. If you know any cloud, okay, mostly I would get the server using EC2. I will get the server. If you have Azure, okay, we call it for EC2, we call it virtual machine in Azure. For if you have GCP, we call it compute engine. The use case remains the same across cloud. Use case doesn't change.
Yes. Okay.
Getting the server, getting the storage, functions like Lambda. We call it Lambda here. For Azure, they call it Azure functions. Google, they call it cloud functions, right? Again, for IBM, there must be some specific function name, right? So the use case remains the same. It doesn't change. We call it IAM here. IBM would be using some other technologies, right? So other terminologies. So we're gonna do the demo using AWS, right? But if you know IBM, it's gonna be a cakewalk for
Can
you
we
to
get
learn AWS.
the similar free trial for IBM as well? Is there any idea?
Okay, IBM I have not tried, but you would
Okay.
get IBM Cloud. Let me check. Every cloud offers. So I know about four. I know about AWS, Azure, GCP, Oracle. I know about these, but Obviously, every cloud offers, every cloud wants you to learn. That's how their business would grow. IBM, let me check it. IBM, yeah, free, yes,
Okay.
free tier. Every cloud has this. They offer some free credit because every cloud wants you to learn so that if because when you learn, then only you will use it, right? And that's how their business will grow.
Yes, yes. Okay.
It's all about business, right?
Agree, agree.
So every cloud offers some free tier for you to learn. So look at this. All they always have 40s, always free products. And just go over this link. You will find a lot of free tier. First cluster for 30 days, Kubernetes service they're giving, 25 GB storage they are giving for all always free trial. Okay, look at this free trial. What they're offering free trial. This much of compute they're offering, this much storage they're offering. They're offering free trials. Create,
Okay.
just sign up, log in, and start using. Same thing, I'm going to do it for AWS.
Okay, okay.
So any knowledge on DynamoDB will be provided along with the course?
Correct. We have a session. So if you look at the course, right? Let
Uh-huh.
take you to the course. So we have a database. So we talk about DynamoDB. So not in detail because I'm talking about cloud. I'm not talking about database, but I'm going to show you how do we create table there, how do we create items there, how do we check monitoring there. I'm going to talk about that. So we have database services. I will talk about that. And DynamoDB we do cover.
Okay, sir. Thank you.
Roshan, in the SRE bucket, you have that SLI, SLO, and
Right.
SLA.
Right.
So those indicator we are going to cover in this, like how to set in the live perspective or the project perspective.
I'm going to tell you what it is first.
Mm-hmm. Okay.
What it is. What do we mean?
Mm-hmm.
How are these important? How what are these terminologies mean first, right?
Yep.
This is from a understanding perspective,
Okay.
from a knowledge perspective. I don't understand what are you expecting here?
No, I'm just expecting like in the practical knowledge how we are setting up this SLI, SLO in the as an indicator in our dashboard or somewhere, right, where we can measure.
Once you understand, right, SLIs are
Mm.
nothing but the indicators like the
Yeah.
response time, your
Mm-hmm.
throughput, your error rates, right?
Yeah.
Specific indicators. So
Yeah.
it's all about creating panels, right? If you have
Yeah.
a dashboard for let's say Elk Stack or Prometheus
Mm-hmm.
Grafana, that we're gonna cover, right? So
Yeah.
we can capture those dashboards. So I'm going to show you the dashboards here.
Okay. Yeah. So here we can means we can make those indicator means how to make it and
Correct, dashboards, panels.
yeah.
Yes, yes,
Yeah.
correct.
Okay.
I'm gonna show you. Yes. Okay, guys, so that will be all for today. Okay, uh, you can join the next session, which is on the next week. Okay, we will talk about the course. We'll start with day one, right, on 17th March, next Sunday, right? We're gonna start with that, and you will understand how we go about things, right?
So the class is going to be weekly once for 2 hours.
No. It's gonna be weekly twice, weekends,
Okay.
Saturday, Sunday. Only for the day one, we are doing it. If you look at after day two, we are meeting every week twice, right?
Okay. Okay.
Only for the next week, we are meeting it once. Uh, Feel free to attend sessions. Okay, have any questions? Okay, first of all, I hope I made your 1 hour valuable because time is very important for me as well. Whenever you will spend time with me, I'll make sure you learn something. I hope you learned something today, right? Uh, do we agree on that? Something
Yes, sir.
Yes, yes.
good,
Yes. Sure.
good. This is what I intended, and this is how we're gonna do it for the remaining sessions. Okay. That's all from my side. Thank you so much, everybody. We'll meet on 17th.
One question from
Go ahead. Go ahead. Go ahead.
Roshan. In comments, Sudhakar mentioned one question.
Okay, let me check. In my previous project, my client asked me to use AI for Chat GPT to boost the performance testing and make automated to sync with performance automation testing. Is it really works? Can you please tell me how? No. I don't know about this. Okay, See, performance testing is something, right? It's gonna be a very depends on use case to use case. See, if I talk about testing, you can automate some. You can write a script using Jmeter or LoadRunner. That is called scripting. Now coming to the analysis, people have been asking how to automate the analysis. There is no way to automate the analysis work to find the root cause. It is a manual process to find the root cause. Finding the root cause is an art. Nobody can automate that. Every problem is different. So you can automate the scripting. We do that using Jmeter, right? So Sudhakar, I hope you're using Jmeter, right? You know how to script. Do you know that?
Yeah, actually, I was struggling in writing custom codes.
So that's a Jmeter thing. Okay, so don't get confused. So you need to learn Jmeter. We don't, as part of this course, we don't teach, I will not able to teach you Jmeter. That is a separate module. You can contact other training of ISA. There are good trainers at ISA who can teach you Jmeter. But to answer your question, that's called Jmeter scripting, right? You can automate that. But analysis, you cannot automate. Analysis is uh, very subjective thing depending on the problem. If you get one problem, you need to, let's say you find high response time. High response time could be because of 5 reasons. You need to know which region is that. It is host server problem, or a CPU problem, or a memory problem. What is the problem, or code problem? Or a network problem. You need to understand, drill down one by one. So you cannot automate the analysis. This is what I always say, and I always believe in. Troubleshooting, debugging is something which is very difficult to automate. Automation testing, you can use Selenium to automate, you can do that automation. But analysis, debugging skill, you cannot automate using any AI tool.
Okay,
It's
got
a
it.
manual work, going over the logs and understanding the flow, understanding the stack trace, right? Talking to the developers. Then only you can fix the problem, right?
Okay. Yeah, yeah.
Okay. Any other questions? Okay. Thank you so much, guys. We'll meet on 17th. Okay. Thank you so much.